Welcome to today's lesson, and today we're going to be looking at the L298N motor controller board. Now this board has a number of abilities. It can control 2 DC motors or it can control 1 stepper motor. Now in today's lesson we're just going to look at the basics of controlling the DC motor, and we're going to see how this can be controlled from our Arduino. And then as we progress through this video, we're going to write a couple of different scripts. The first one will be the very basic control. The second one, we will use functions to simplify our code and make it easier to understand what is going on. So that's the plan for today. Let's get on with it. So we'll start by having a quick look at the board. Now the motor controller board, although it's called an L298N motor controller board, the L298N bit is this component here. As you can see, it's connected to a heat sink because these things can get a little bit warm, so need to dissipate heat. But the rest of the board basically is there to allow us to connect to this component without having to build the circuit ourselves. So let's have a quick look through the different bits. If you go to the Digital Town website, it's got some circuit diagrams and some more explanation of these bits, but we'll have a quick look through here. So we've got 2 connections on the left, 2 connections on the right, and these are where you will connect your DC motors for this particular example. On the front we have a 12-volt connection here. We have although it says 12 volt, in our particular, if you're doing the robot car, you're probably putting in 6 or 7 volts, something like that, depending on the batteries that you've got, but that's fine. It will actually take up to 35 volts, but you don't want to drop below 5 volts. So although it's called a 12 volt in, it is a little bit, a little bit flexible. In the center we have an earth connection, the ground, and then on the right there is a 5 volt output, which we will not be using today. Now as you look at the board, you will see a connector just here. Hopefully on your board this connector is fitted. This little connector means that some of the power that, if you like, is put into this board is converted to 5 volts, and we will use that 5 volts. Although we're not going to use this connection here, we will use the 5 volts down here. So if we look at this section of the board, the ENA and ENB stands for enable motor A or motor 1, and enable motor B or motor 2, as I call it. Whatever you want to call it, it's fine. Now what this is a bit like the master switch. So if this isn't connected to 5 volts, this motor will not run, and if this one doesn't have 5 volts, this motor won't run, no matter what signals you send to it. Now we could connect this to an Arduino pin and send 5 volts, but by putting these little clips over, we actually link between the enable pin and a 5 volt pin behind, so we keep the enable pin held high. If you remember, when something's high when we're programming, that usually means it's at 5 volts. So by keeping this pin held high, the motor is ready and waiting. If you like, the master switch is on and it's waiting for our inputs. Now our inputs go on these 4 pins, IN1 to IN4. I guess they stand for input 1 to input 4, and these are the pins that we will also connect to our Arduino that will send the digital signals over to let the board know what we want it to do. So what we'll do now is have a quick look at a circuit diagram so you can start to see how this is going to work. So here's our circuit diagram. We can see our L298N, and as you can see on this diagram, because it's for the robot car project, there are two motors on one side, two motors on the other side. Now you'll remember that I said at the beginning that the board can only control two motors, but when the two motors are connected through the one connector, it treats them as one motor. Now obviously when we run the test script, the important bit that you need to be checking at the beginning is that both motors on one side are spinning in the same direction, otherwise your front wheel will go forwards and your back wheel will go backwards. Now you might wonder why we use this board. Well, the Arduino itself can actually give out 5 volts, but the number of amps it puts out is minimal. It could never power a motor. It would just melt our Arduino. So this is why we use the driver board, and if you look at the circuit, you can see that our battery power goes in to this board, and then that in turn goes through this L298N board, and that then gets sent out to the motors. Again, if you go onto the Digital Town website, the circuit diagram is there, and as you can see, I've put a note on, make sure these connectors are on, and obviously the connector here needs to be on. As you'll see, we need to connect the ground to the ground on the Arduino, and then you'll see that we've got 4 wires going from the different inputs to a set of input pins on the Arduino sensor shield. Now I've brought up a bit of an enlarged version of the sensor shields just so you can see clearly. We will be using pins 11, 10, 9 and 8, and your pin from the IN 1 to 4 will be connecting to this line of pins that have the S. Now G, and you'll see G is on all the back rows, stands for ground, and that's that black wire that's coming across. You could connect it to any of the ground pins. One of the reasons that we use a sensor shield is, if I just move this up here to a picture of the Arduino only has a couple of ground pins, and if you're building something quite complex, it's very easy to run out of ground pins and even 5-volt pins. By using a shield such as this, if you look on the center row where it says V, these will all be 5-volt pins, and G will all be ground pins, and then of course we can connect to our digital pins. They're all numbered up here just the same. So as we look at our circuit diagram, that's what's happening. These input pins are connecting to a number of pins on the sensor shield, which in turn connect to the Arduino pins. You could connect directly to the Arduino pins if you don't have a sensor shield. Doesn't make any difference whatsoever. Just make sure you connect to the same numbers and it will all work. So that's our circuit diagram. Now we're going to get on and start to look at how we control this board. So what we're looking at now is a list of the different pins as we've seen on the board. We have our enable pin for motor A or motor 1, our enable pin for motor B, motor 2, and then we have our 4 pins IN1, 2, 3 and 4, which control the motor. Now as you can see, I've written on here what they do. This chart is available on the Digital Town website. The link will be below the YouTube video, and as you can see, if pin number 1 is basically the forward control for motor A, pin number 2 the reverse, pin number 3 the forward for motor B, pin number 4 the reverse for motor B. And if we look down here, I've done a chart to explain how all of this works. So as we've seen, our ENA pin, our enable pin, we've already got it locked to being 5 volts high. So if you remember from the digital write lesson, if you haven't done that one, take a look at that lesson. When something is high on an Arduino UNO or a Mega, then it's basically sending 5 volts. So if enable is set to 5 volts but pin 1 is no volts or low, pin 2 is no volts or low, then motor A will be stopped. If the enable is at 5 volts and IN1 is at 5 volts and IN2 is at no volts, then as we've seen from further up, the motor will start to turn forwards. And again, the opposite, if IN1 is at 0 volts or low and IN2 is at 5 volts or high, motor A will run in reverse. Now, of course, if you accidentally go and set IN1 at 5 volts and IN2 at 5 volts, motor A is going to stop. It's not going to go anywhere. That's part of the logic that's built into the board. And then we see with ENB exactly the same thing. Pin 3 and 4 both set to low or 0 volts, motor's going to be stopped. IN3 to 5 volts or high and 4 to no volts and low, motor B is going to go forwards. And again the opposite, 3 at 0 volts or low, 4 at 5 volts or high, motor's going to turn in reverse. And again, if you set them both at 5 volts, both at high, the motor's going to stop. So that is, if you like, the control system for the board. And now what we're going to do is write our Arduino code so that it sends the relevant pins, high and low, to control the motors as we want them to be controlled. So here we are in the IDE, and as you can see, I've set up the code in the usual way that I would write it. I've got my code name, it's L298N V1, and then I've just added basic control afterwards so that when I look at it in my sketches folder, I can look under the heading of L298 because I'll have a number of sketches in there for controlling this unit. And because I now know that it's basic control, I can look and think, okay, I know what I did in that sketch. Again, it's that way that we looked at in the early lessons of versioning software to make sure that we can find information when we need it. Again, a little bit of information in here about setting the jumpers. I'll often do this in my sketches just to remind me when I come back to something months and months later of just how to set up an item. And then here is something that I do a lot. This is where I list which Arduino pin is connected to various items. So in this case, pin 11 on the Arduino is going to go to IN1 on the L298N. This is useful for me, especially in bigger projects, because okay, at the moment there's only 4 pins in use. But if you could imagine if we were using a Mega and we've got 54 pins and we've already used 25-30 of them, if you don't have a little bit of a list of which pins have been used and suddenly you want to add a new item, all of a sudden there's that thing of, hang on, which pin is free? So if as you add things, you put them up into your header, your comment box, it just helps you long term in how you find what pins are available. Again, we have to have a wire from the Arduino ground to a ground pin, and again on the circuit diagram as we've seen earlier, it shows how to do that. Now, as we've already seen, we're going to use certain pins, and if you remember the chart that we looked at, it gave us the connections and it told us what each of these pins would do if it went high. And so what I've done now is translated that chart, and with the pin 11 here that's connected to IN1, that is the left motor reverse. Pin 10, left forward pin. Pin 8, right forward pin. Pin 9, right reverse pin. Seems a bit of an odd order, but it's just the to be honest, it was the way that the wires went over quite nicely off the shield, and sometimes that's just the way it is. Now, one little thing about this, sometimes if you wire something up the wrong way, there can be that sort of thing, hang on, I've got to unplug everything. But there are ways, because we define these pins in software, if you can imagine if I plugged in these 2 pins back to front, all I would actually have to do is change the pin numbers over, and I wouldn't have to physically change any of the wiring. So that can be very, very helpful as you're working in your sketches. Saves you having to get the screwdriver out at various times. Now again, there's my standard header in here, so that when it fires up I know which code is actually on the Arduino board. And then if you remember, if you did the digital write lesson, you'll see that not only have we defined our pins, and again we've used a constant integer, so that is an integer that cannot have its value changed, because there's no reason why we would ever want to stop pin 10 being pin 10. The number is what it is and it stays the same, so we don't enable it to change, and we fix it by putting that const in front. Now here, if you remember the digital write lesson, if you've done that lesson, you'll see that we have pin mode. So we're saying that the left forward pin, pin 10, is going to be an output. It's an output because we're going to be sending data from that pin, and it's the same with all the other pins. We declare them all as outputs, so the Arduino knows that it's going to send a signal. Now when it sends that signal, obviously if the pin is sent to what we call high, it's going to send its 5 volts. If it's low, it's going to send no volts. So looking through the main loop, all this script does, it's very, very simple. The first thing it does is it sends something to the serial monitor. This helps me to see if I'm testing a car. It's quite useful to know that if I'm making the wheels spin forwards, do I know that I've sent a signal that's sending it, telling the wheels to turn forwards? Because it means if the wheels start to turn backwards, I've probably wired the motor back to front. So as this is a test sketch, it's useful to be able to have that bit of information in there just to let us know what's going on. So we're going to send the motor forwards, which means we're going to set the left forward pin to high, and we're going to set the left reverse pin to low. Now I've put that in as an example just so that we know exactly what's going on. And then we're going to use delay. I'm not a great fan of delay, but nothing else is going on in this script. So what will happen is the motor will start to run forwards because the forward pin is high, the reverse pin is low. Then the Arduino will wait for 5 seconds, so the motor will literally run with the left wheels turning forwards for 5 seconds. Then what we're going to do is we're going to turn the left forward pin low. So at this point we're going to tell the left motor to stop turning. Again, we'll wait for 5 seconds. Then what we'll do is we'll reverse the left motor, and to do that, all we're going to do is we're going to set the left reverse pin to high. Again, wait for 5 seconds, and then we're going to stop it again. Once we've done that, we're going to do exactly the same process with the right hand motor until everything has gone through an entire loop, and then of course it will loop all the way back and it will start again. It's a very, very simple script, and I've already uploaded it to my Arduino board, and if I load it up here, you can see this is what you'll see. The left motor is going forwards. 5 seconds we stop the left motor. 5 seconds we reverse the left motor. 5 seconds we stop the left motor. And I haven't got it plugged in with my motor running at the moment because it would make a lot of noise on the microphone, but if I put the batteries in, basically my motor turns according to this script. And if you've got this working and you understand it, what you've actually managed to do is control a motor from an Arduino in a very, very simple way. And also, if you're doing the robot car tutorial, you'll actually know if you've wired up the motors the right way round. So this is the first script. It's a very, very basic script, and it's just there to test the motors. What we're going to do now is I'm going to bring up another sketch, and I'm going to show you how to improve this so that we can take control of the motors in a far simpler method. So this time we have two scripts up on screen. The one on the left hand side is the one that we've just been using, L298N version 1, and on the right hand side we have L298 version 2, and notice I've changed the end of it control functions because this time we're going to use a series of functions to make it easier to control the car. Now, if you don't know how functions work, you need to go and check out the lesson in the C++ tutorial on the Digital Town website, and there's a whole section on how to start to use functions. So let's first of all go back to our original script, and if you remember, we were writing to make the left motor go forwards. We wrote the left forward pin high, the left reverse pin was low, then we stopped, we waited for 5 seconds, we stopped, so we turned off the left forward pin. Now the issue with this, if you can imagine, if you wanted to do a whole set of instructions for your car, you would have to keep remembering which pins were high, which pins were low, and if you can imagine, if you wanted to change the order of things, it would become absolute chaos. So this might work for a very simple sketch to test that the board is working, but as something to use for something controlling a car that will become far more complicated, it's just not going to hack it. And that's why we start to use functions. So on this second sketch, again, all the pin configuration is exactly the same. The setup is exactly the same, but the changes come in the main loop. And you'll see here that I've started off by calling a function that's called drive forwards. Guess what that function does? It makes the car drive forwards. It's as simple as that. And what it does, if I scroll up here to the function drive forwards, there it is, you can see that it sets all the pins correctly. If you remember back to our chart, if we want motor A or motor 1 to go forwards, IN1 is high, IN2 is low. If we want the other motor going forwards, then IN3 is high, IN4 is low. So what I've basically done is written out that whole chart, and on this one, to drive forwards, it puts the right forward pin high, the reverse pin low, the left forward pin high, the left reverse pin low. So at that point the car is going to go forwards, and I did a sort of serial print at the top just so that I know both motors are going to go forwards. I also created the opposite function, drive reverse. This time the forward pin goes low and the reverse pins go high. I did another one called stop motors. Everything goes low, everything is stopped. And then what I started to do was write other functions. So we'll see here forward right. So to turn right going forwards, the left hand motors will go forwards. So what happens here is we see the left forward pin goes high, the left reverse pin goes low, and of course on the right hand side I set both the pins low. Now the reason I'm setting all the pins in every function is it means that when this function is called, I don't need to know the state that the pins are currently in, because the function will do absolutely everything for me. And so as you look down, basically what I've done is I've taken our chart down here and I've made it into a set of functions, which means now when we go to the main loop, instead of having to think about the pins, all I do is I call the function drive forwards. I'm going to keep going for 3 seconds, then I'm going to stop the motor for 3 seconds. Then I'm going to go forwards and right for 3 seconds. Then I'm going to go forwards and left for 3 seconds, and so on. I'm going to work through all of these things. But it means if all of a sudden I wanted to change the order or repeat something, let's imagine that we want to what are we going to do? We're going to reverse right, and then we're going to reverse left, and let's reverse left again. And there you see, it's as simple as that. I can literally put my reverse in. I can change the order of these things however I want without any problems. I can change the timings by just altering the delays at this point. And so as you can see, at this, by changing everything to functions, I then don't have to remember any of the current pin settings. I can change the order however I want. And this is important because as we develop our car and we want the car to start to do things automatically, it needs to have the settings correct, and it doesn't need to keep reminding itself what it was doing before. All we do is it will come up maybe against an obstacle, and then we would say stop the motors. If the obstacle, if the car then needs to get out of the way, it would know call the drive in reverse function, or it would call the function to turn to the right or turn to the left. So by reducing this to functions, it makes the code far more readable, and it allows you then to use things going forwards. Let's imagine we were doing a radio, we could connect via Bluetooth or a radio control or an infrared control, and if we then said, well, I want the car to go left, all we have to do is call the forward left function. So the functions at first, they look a little bit sort of complicated and it looks a little bit more work, but the fact is that I've only had to work all of this out once, and once it's done I can just call them endlessly, not just in this script, but I can then copy these functions once I know that they all work into future scripts, and we will reuse these functions over and over again. So you're starting to see the power of functions and how now the code is far more readable going forwards. We can now see exactly what's happening, and because we have our serial print, I'll just bring up what's actually going on. So you can see both motors are running forwards. I then stop the motors. Left motor forwards, it's going to turn right. Right motor forwards, going to turn left. Stop the motors. All of these things, it's working through my list of functions, and it's very clear to me as the programmer exactly what I've written and how it's all going to work. So I hope that extra little script helps you going forwards. It's a script we will use with the robot car going forwards, because we will use those particular functions over and over again. So you've seen the power of functions and the fact that once you've written them forever. And as we can see here, if we wanted to add extra things, we could copy every single instruction we've done and paste it in again, and we don't have to worry about any changes of pins. It's all taken care of. So a quick recap on today's lesson. We've learnt to use the L298N motor controller board. We've got a little bit of understanding about how it controls DC motors. Stepper motors are for a later lesson. We've done a basic DC motor circuit. We've connected it up to the Arduino, and we've controlled it firstly with a basic set of controls from an Arduino, and then in our later sketch we've used functions to simplify the code. So again, if it's useful to you, click the like and subscribe. Hope to see you again in the next lesson.